everyone. I'm Rashmi Nagpal. I'm a machine learning engineer by profession and a researcher by passion. So this is my first CodeBeam talk, and I was telling the other days to the organizer, especially Barbara, I'm a little nervous, but really excited to actually share my learnings with all of you. So let's begin. So the topic of my talk is definitely to build, unbiased machine learning systems using the Elixir, and let's see how it goes first. So first of all, I'll just give an introduction of this topic, so bring all of us on the same page that what is machine learning and why sometimes machine learning gives unbiased results and responses, and how we can actually build certain machine learning algorithms or techniques around it to mitigate any of the fairness or maybe like unbiased issues. Biased issues per se. So AI is a very broad term. It implies that any kind of a program or a technique which mimics the human behavior. And machine learning is nothing but it's a subset of AI. So in machine learning, you are given a labeled data set as an input, and then it gives you some data-driven decisions. While deep learning, which goes one step beyond machine learning. So you are extracting the patterns from the data, and then you are giving, some data-driven decisions or predictions around it. So one such example is handwriting recognition, and spam email detection is an example of machine learning. So let's see. Now I explain you the basics, and that's so very tricky, and I actually love this. So I just want to test the waters. I want you to take a minute and think. Think which of these faces are real faces. Okay, now please raise the hand if you think face A is the real one. Interesting. Please raise the hand if you think face B is the real one. Please raise the hand if you think face C is the real one. Well, I'd love to have more and more participation, and I see like approximately 65% in the audience have raised the hands for either of these faces. Well, the truth is none of these faces are real. So, these people do not exist on the planet Earth, to say the least, but I'm not sure about the extraterrestrial planets. So this is an application of the deep generative modeling. You must have used like ChatGPT, DALL-E. These are all, deep generative modeling use cases and examples. So what happens in the deep generative modeling is, you're not just getting data which the model is ingesting to give you some output or data-driven decisions, but actually it is going one step ahead. It is synthesizing the brand new data instances based on certain learned pattern from the existing data. So let's understand what is the building block behind all of these machine learning, AI, all these deep learning algorithms. And that's where the neural network comes into the picture. So this is a basic structure of the neural network that, given a data set as an input, consider machine learning right now as a black box, which comprises on weights, sum and bias, and activation function. And then it gives you an output. Output could be anything, it could be any real use case that you're catering to. It could be, like image recognition use case that you're catering to, or maybe a sentiment analysis. So let's understand this basic structure of this neural network through an example. This is a use case, and that's my Fluffy, my pet dog. Given an image, you need to identify to which animal category that image belongs to. So first of all, what you're going to do is feed the image dataset as an input, and then because it's an image, right, so you need to do some computation around it, so it will ingest in the form of zeros and ones, and then you apply some machine learning algorithm or image classification algorithm, and then it gives you with certain confidence that, this image belongs to dog category with 82 or 92% confidence, or maybe it belongs to the cat category with 8% kind of a confidence. Now, if I want to deploy this entire image recognition use case in the production environment, so let's see how our machine learning pipeline will look like. So this infographic basically gives you a high-level overview of how our machine learning pipeline will look like. So first of all, you have the build stage, in which you are not just ingesting the data set as an input, but you're also doing some pre-processing. And then you're building a model, doing the model testing. If you're very much satisfied, then of course you are packaging the model in the deployment stage. And then it goes in the monitor stage. So in the monitor stage, if you feel a model is deviating from the predictions or the exact output that is required, then of course you're circling back to the build stage. So this is how entire, the end to end, I would say, or the bird's eye view of the machine learning pipeline looks like. Now let me ask a question. What if happens if any of the stages fail? It could be like build stage which is failing, or maybe like, the deployment stage which is failing, in a sense that the model is not giving the results as to what is expected. So I'll actually give the example, and I'll have like bunch of other questions, so I just want to make this talk as interactive as possible. But just to explain you, if there is something which is failing in any of the stages, do you know that 13% of machine learning models never make it to the production? So it implies that the rest 87% are actually never see the day of the light. So that's a staggering number being given by the venture beat recently. So we need to understand what are the strategies that we can use whenever we are building or deploying, or maybe like just doing production of the deep learning systems. So first of all, the main important part of this black box problem or the machine learning problem is what exactly it is. That's the core of this talk is going to be. So this example right now shows a word-to-vec embedding. So what happens in the word-to-vec embedding is the words are represented in a vector space, or you can understand it's a Cartesian plane in which the words are, there are certain vector dimensions around it. So you can see in the word-to-vec, or the intuitive meaning is the words which are closer in the meaning, right? The words which are similar in the meaning, they are going to be closer in this entire vector space. So does that imply the homemaker and a woman, are they similar in the meaning? Well, the truth is, unfortunately, that's true. The rationale of how this bias is created in this word-to-vec embedding algorithm is because it's being trained on a Google News dataset, which is highly biased dataset. Next example that's very interesting, and I'm really sure that people must be using the ChatGPT. So I'll just give like a couple of seconds so that you can read through the prompt and the very surprising responses given by the ChatGPT as well. Okay, so the prompt that I gave to the ChatGPT is the doctor yelled at the nurse because he was late. So the question is, who was late? And the response given by the ChatGPT is the doctor was the one who was late. Right? That's not so true, right? Our logical deduction says that the nurse was the one who was late. So you can see how the word vectors, the embedding have been created with certain occupations over here. And as a similar example, the next one is the doctor apologized to the nurse for her late arrival to the emergency room. And then who was late previously? So of course, because the doctor was the one and the doctor is a her, right? So, there are like so many algorithms which are built behind it, and it's not necessary because of the data. I'll explain certain strategies that how we can actually build unbiased, fair machine learning systems. So let's see. First of all, just to understand how we can mitigate, we need to know what could be the possible causes that why sometimes it gives you biased responses. So there are like bunch of, again, this is not an exhaustive list, but very well spans over the entire idea that why we get like unfair responses. So when you have the biased training data set as an input, that could be one potential reason. As we say, garbage in, garbage out, right? So if you're feeding in the skewed data set distribution, then of course you're going to get the skewed output. And when you have the lack of diversity or well representation of the within the data set, of course the responses are not going to be, like justified within the entire span of the distribution of the data. And the third is a cognitive bias. So sometimes we are also not aware of the biases which is inherent in our systems. So cognitive biases or selection biases, there are various versions of it. So when you're not aware about it, then how we can actually do it, understand it, that's there is a very famous matrix. When you say like knows no, or when you know like no unknown, so that kind of a cognitive bias is something we need to deal with it. And when you have the inadequate evaluation metrics, when they're not aligned with the objective that we are trying to achieve, therefore it will also lead to sometimes haywire results or responses. Now, after pondering over those couple of examples and their biased and unfair outcomes, now it's time for us to introspect that how we get here and how can we build the models which will give you, some fair results. So there are like bunch of techniques again here when how we can mitigate it. So first of all is, when you can have a diverse data set, it's much more important and also justifiable so that you can have well represented output as well. And sometimes when you have the biased or discriminated data set, then it will actually amplify it, or it will perpetuate towards the underrepresented sections of the society. So lack of diversity is also one such rationale that you need to have it, because otherwise if you have the lack of diversity within the data set, then it will of course lead to skewed results, and again garbage in garbage out is the response that you will get. Next one is something like you can use some techniques like pre-processing the data set. So there are some data augmentation techniques, there are feature engineering techniques that we can use. I'll actually give an example so that it could be comprehensible in the subsequent slides. Third is when you have the fairness techniques, right? So what I meant by the fairness techniques is, let's say within the data set, you have certain sensitive attributes. And that's also one such topic of my research, which I'm doing is, for example, given a data set, you have certain protected attributes. It could be age, demography, ethnicity, gender, or anything like that. Now you want to build an algorithm which is not biased towards any of these sensitive attributes. Those are like called as fairness techniques. In a sense that the model that you have built is fair across different protected attributes. The fourth and the last one is you need to test your model thoroughly. It could be unit testing. We'll also see how we can do it in subsequent slides. But the rationale is you need to get it vetted through clearly and just see how the model is giving an output in each and every stage in the machine learning pipeline that we saw earlier. Okay, so this is an example of the loan classification. First of all, I'll explain what we are trying to do in here. So first, given a data set, you want to understand how the model is going to respond with regards to certain the German credit is one of the data sets. It's freely available on the UCI repository, which has certain attributes around it. And the attributes are like the status, duration, what are the savings of the user, or, like what is the gender of the user and to which ethnicity they belong. So first of all, you pre-process. Of course, you need to load the data set, pre-process it, and then you are encoding. Why we want to do the encoding over here is because there are certain categorical attributes within this data set. So you want to convert those categorical to the numeric version. And then you want to understand, you want to understand how the model is going to respond once you have done some data augmentation techniques around it. So you do the one-hot encoding is one such technique which actually helps in disintegrating your categorical into the numeric ones. And then you are doing splitting of the data set. So we want to split the data set. The rationale behind any of the ML algorithms is you given a data set, you divide it into certain training, testing, and validation. And it could be in any of the ratios. It could be like 70, 20 and 10, or maybe like if you just want to do how the training and the testing, then of course you can do some training and splitting. So it could be like 80 and 20 kind of a ratio as well. So once we have done it, and then I'm right now using over here is a SMART technique, which is synthetic minority oversampling kind of a technique that we are using, in which if there is a minority within the data set, then you want to understand or make it like it's very well used in the imbalance classification. You just want to balance out the targeted values within your data set. So you can see that before applying the SMART technique, the distribution of the zeros and the ones, and that's talking about the targeted values. It's 569 and 551. But after you apply the SMART technique on the data set, now there is an equal distribution. Now, the next part is the ML test pyramid. We have pondered, okay, there are certain techniques that we can use, but how can we actually introspect that, how can the models that you have built are fair enough? So let's see. So a bunch of testing techniques are there, like the unit testing in one such. Unit testing, you're just not testing particular part, but actually you're testing the individual components of this ML system. What I meant by the particular component or the different components is either it could be a data pre-processing stage, or it could be the modeling stage, or any other feature engineering or pre-processing stage. And you are just dividing this unit testing in such a way that you are not just testing the individual components, but also like the essential part of it. And integration testing, again, it just verifies whether interaction and the integration with the different systems is also like the version or the different, the components of the ML system is performing as to what is needed. And the model testing. So this is, I think, whenever the data scientists or the developers building any model, they are also using their own evaluation metrics. If that's a classification, then accuracy, precision, PRF scores, which is called as recall, these values are used. But there are other techniques as well that, if you're building a regression, maybe like MSE values or loss function and all of these things that you can use. Next is the robustness testing. You are just trying to understand how the model is performing across certain edge cases. For example, you have built a model in 2019 and still that model is in production environment in 2024. Now the model is going to be stale because it has been trained on a very late, it's on initial versions of the data set. So you have to do some robustness testing around it and just to see whether the model needs a tweaking of the hyperparameters or certain other parameters. So that's what the robustness testing intuition is coming from. And the other is the deployment testing. Again, validating your model is performing in not just in the simulated environment, but in the real world scenario. And fairness and ethical testing is also one such component that we can use to evaluate whether a model is not giving biased responses towards certain section of the society or maybe like towards the other outputs that we really need. And I think one of the very cool thing with the Elixir that, it has like large, for example, in every machine learning or the deep learning environment that you are working on, it has like large volumes of the data set as an input. And I think the fantastic feature that the Elixir has is about having this concurrency kind of a principle. Therefore, it just allows, several computations that can be executed at the same time instead of sequentially. And that saves a lot of time. So this example about the sentiment analysis, again, this is just a testing example because I've explained various type of testing before. First of all, I'll explain what is a sentiment analysis. First of all is like, let's say I'm saying that I don't like the pineapple on a pizza. Not sure who likes it within this audience, but it's absolutely no for me. Or I can say, I'm actually really grateful to the organizers for giving me this opportunity to present here. So it's a positive sentiment, right? And the pineapple on a pizza was a negative sentiment. So that's what the sentiment classification is, what I want to do. And here in the first part, you can see that okay, I'm assigning a score. You already have a dictionary. There is a mapping of certain words. Let's say there is a bad, there is a good, and you're just assigning certain values to it. So what I'm trying to do is you're creating the dictionary. You're given a sentence. You're defining a score to a sentence. If the score is coming around like something less, then of course it's a positive, or maybe like if score is reaching at actually a 0, or maybe like it could be a neutral value. And if it's of course, if it's less than a certain threshold, then it's going to be a negative value. And then the other part is about testing, how we can actually test whether the model is performing really well. Of course, when there is no sentence being given to the model, then it's going to be like a neutral. You can't see even a positive because the score is not going to be any of the values. And if the score is like greater than 0, then of course it's positive sentiment. And here I've also like given an example, so excited to participate in this conference. The other is like there is such a terrible movie, so score is of course going to be less than 0, right? So it's a negative sentiment. So this is how you can actually, it's a very basic example, the rationale why I'm also giving this talk, because Python is kind of, so someone was asking me the other day, why not we do the machine learning heavily in Python? Sure, we do like heavily in Python, but Elixir also has fantastic components that we can leverage and also we can do it with ease. So I think that was one of the motivation why I applied to this conference too. The next is, okay, we have seen, how we can actually build models. We can do some mitigation strategies so that the model is giving some unbiased and fair responses. But the question which I really wanted to ask you all is, who should be responsible for the ramifications of the ML model? Sometimes the model is giving this huge distribution of the responses, then who should be one pinpointed at? So the options are data scientists or the developers, business leaders or regulatory bodies, or customers. And I would love to see any volunteers who would be giving this answer within this. Yes, please. Yeah. Okay. Right, that's fair enough. Anyone else? That's fine, yes. Okay, I think anyone can just answer. Doesn't matter. Yes, sir, please. Yes.
Okay. Well,
Right. That's true. Yes. But your answer, so too? Yes. Okay. So you are saying like multiple answers? You are saying that, okay. Well, the answer is, because there are like multiple stakeholders involved in this development, maybe like building and deployment of the ML systems, could be developers or data scientists, anyone. I don't think that we can fairly pinpoint one person out of all these four, but because it's a it can't be like a sole responsibility of one individual out of all of them. So I think it's very indispensable that for every stakeholder to take care of the responsibilities with a perfect plan and caution. It does sounds like there is a very famous meme actually. There is a Spider-Man actually pinpointing all of them all together. So I feel like together we all can build a very much well represented, or I would say a holistic and ideal kind of a solution. That's 100% not so true in an ideal situation, but surely we can reach and aim towards it. The next is, I think this is the part which I always wonder that why we feel that the transparency and the trustworthiness is also like equally important whenever we are building. What I meant by the transparency and the trustworthiness is because, we are using a lot of applications which are embedded with not just machine learning. There are different use cases around it, and the stakes could be like super high. So we really need to understand what is going behind the scenes around this black box system. So again, this is an example of this autonomous driving in healthcare. Like these are the certain applications around it. In the medical diagnosis or maybe like healthcare or any other application for that matter. See, when you are making the slides towards the last minute, then you forget about removing certain titles, right? So it's not related to at all like sentiment analysis classifier. This is just an example about how we can build, why we need to build trustworthy and transparency models. So I was just saying about when the stakes are like super high in certain applications, the decisions made by some of the ML models, they can actually leave a significant impact on the people's life. Therefore, it's very much critical for the users to understand, how the ML system is actually working behind the hood. They also need to understand how the system works and how it makes certain decisions around it. Therefore, it's important that needs to be, who should be actually responsible for any of the ramifications that this model is going to produce. And the next is, how we can actually build trustworthiness and transparency whenever we are building ML system. How can we actually embed around it? So again, see, I copy pasted a couple of slides, and when you're doing it last minute, you see the title is not being changed. So, well, the response and the answer to the previous question is you need to actually have the high quality data set and use some explainability and interpretability kind of a models, which will help you in justifying, for example, let's say to the sentiment analysis example also, you see that I'm very much grateful to the organizers of this conference for giving me this opportunity. It's a positive sentiment, right? So there are certain words within this entire sentence which are contributing towards the positive sentiment. So if our model is able to give us a justification that because of those words or the vectors per se, in machine learning system, vectors per se, and gives you the reason behind because of these vectors contributing that it is a positive sentiment, and that's what the explainability comes into the picture. So we need to know behind it. And third one is also you need to monitor and test your model again. And so this is a regularization is also one of the hyperparameters whenever you're tuning or building such models. So it's something around, you need to actually get it done so that there is no such overfitting or underfitting within the data set or maybe the model in itself. And involving a lot of stakeholders which are actually responsible for building this entire system around, that's also like equally important. And also just regularly updating your model so that the code in itself or the model or the data on which it has been trained, it's not stale at all. Okay. There are a bunch of the technical debts I think we really face whenever we are building the ML systems. And I think we need to know what are the rationale behind it and how we can actually mitigate through those. So bunch of techniques, again, not an exhaustive, but fairly does cover a lot of span of the examples, is like the data depth. When you have the low quality of the data set or smaller data sets, but you're actually training a bigger model on the smaller, so it's going to be not giving a good answer or the prediction. And when the architecture is also like overly complex that you actually can't make it modular or, it's highly coupled with each other. So there is a talk in the next section which is going on how we can actually do the legacy code. I think that's very much suited for this architecture tech. The third one is when the algorithm. So because the ML or this AI space is expanding too much. So, if you're not, I'm not saying that we need to catch up with the pace of it, but actually we need to understand how the new algorithms which are coming up day in, day out, they are performing really well. So our algorithms which we have used like before in our system, we need to like really update it according to those parameters or according to the new architectures or the models which are coming up. And the fourth one is the lack of monitoring. When you have not built, the monitoring system within the place of any of the ML application, that also leads to such technical debts. Testing when it's not well tested, so that's very much intuitive. You don't have the well thorough vetted system around it. Because you really need to catch the bugs and also make the code model and just debug a lot of issues which possibly could arise. And I think the last one is documentation depth, which I really face a lot because we as coders, I think we are like, or maybe like I think I'm just generalizing and all, but at least I really don't love documenting whatever written. And that's really, when you're onboarding the new engineers or someone who is like just recently starting, so it becomes like a kind of a bottleneck for the others to impart the knowledge. So I think the documentation depth, or maybe like say, maintaining a proper documentation is like equally important just to understand, you're not facing through this any of the technical debts. Again, there's certain ways how we can mitigate it. So first is we need to review our ML pipeline. It could be data collection, pre-processing, or any particular stage in this entire system. And just look for any manual hacks or maybe like, steps if there are, or possibly the shortcuts which must have been taken at some point. And just address them by making it like automated or just streamlining the process in general. And poor quality data, again, it's kind of one of the major sources of the technical debts. So look for any kind of missing values or biases, or could be like errors. The label errors could be there, or feature distribution errors could also be there. So just try to address them by improving the data collection pipeline or just cleaning pre-processing pipeline in this ML system. The third is you need to examine the model performance, just updating different parameters or metrics around it over the period of time. Not necessarily that the PRF scores or precision recall scores are going to work like for every possible time whenever we are building ML systems around it. And there are like a lot of tools like Sharp and Lime. These are being used for explainability. So you need to, also like depends whether we are building a text kind of a data, we have images and audio, different kind of data sets. So you need to have a different explainability modules within it so that you can understand how your model is working and giving you the response or an output on the basis of the data set that you have ingested or for your use case. And then the testing process, need to be like thoroughly tested, maybe like using some automated testing strategies, integration unit, and all of these end-to-end test. And the last one is performing the regular code refactoring. I think I also actually enjoy whenever I've written a code which is previously, so I forget like what I've written like 2 days ago. But it's always necessary to have the code refactoring technique in place because you always want to understand, how can I optimize this particular, maybe what's the time or carbon emissions, or maybe like different factors that you can use it so that you can make your code much more modular and also like well intuitive and fresh. Okay, so the conclusion of this entire talk is, building the fair and accountable or maybe like trustworthy models is definitely not like a single day kind of an, problem that you need to solve, but it takes like a lot of time and there are crucial elements around it. And why it is important is because it needs to be well representative and it should be benefiting to all the end users that we are catering to. And we need to ensure the transparent and interpretable models is because we need to understand or so that we can also detect the biases, but also need to understand why our model is giving some haywire results around it, right? And testing is like the thumb rule. It needs to be, it's very important that we need to have a comprehensive testing strategies in place so that we can ensure that we build fair, reliable ML systems. That's me because I love writing poetry. So it's like from data's haze to the ethics place in the ML maze, let's shine the fair rays. And inclusion is our mission, right? A colorful composition, erasing biases is kind of an unwavering vision. And these are like bunch of resources for the future reference. And thank you so much.
So great job, Rashmi. We have a few minutes for questions. If anybody has questions here or on our online, put your questions in. Oh, hello.
My name is Oladipo. All right, let's see. After you've gone through best practice, just like you've run us through today already, on deploying machine learning models that fit and ticks all the boxes, basically. How do you prevent that model in production from poisoning, where adversaries are trying to cause your model to misbehave and act in ways that were not originally intended?
Right. I think adversarial machine learning is also like a domain in itself. It's not like, I mean, they are definitely, there is an overlapping between it. And there is a data poisoning. There could be like certain other aspects around it when your model is stale. But having, I think the short answer I would give is having a thorough testing strategy around it, and also doing, before even deploying into the production, why not simulate in an environment, maybe like staging or other development environment, and just test it out how it works and responses with regards to the adversarial testing techniques.
We have an online question from Bobby. Could you talk about your experience building trust with users of AI?
Right. So I think that's an interesting question, because trust with the users, I think it happens over the time. I don't know. For the chat GPT also, we do trust it blindly, but it also still has issues, right? So I think it's a two-way street, that how you can actually improve your model, which you are building over the period of time. It could be, like different steps around it. So I think getting the trust of the customers is really important, because that's our end goal, to get the ROI. But I think it takes a lot of time and effort in order to understand and comprehend what the needs are and how our model is giving like skewed results, or not fair results enough. So yeah, I think that's what my answer is.
Okay.
For the explainable and interpretable aspects of the model, do you have any tips about ways to approach that? Because I think that's always kind of a difficult thing to.
Yes, that's true, 100%. I think the products, or maybe like a lot of tools which are yet not being released, or I would say they're still in the process, and that's a very hot research topic also. But Sharp and Lime, as to what are the two tools which I have also mentioned in my talk, is one can actually look in for. But how we can actually go through and see, how we need to build and see through the lens of it is just thinking from the user's perspective itself. For example, if you are building this autonomous vehicle systems, so had the, if our model, which is working behind the scenes, if it is giving you some random decision, then your user is definitely his life as at stake, right? So understanding from the user perspective, and also integrating within your model in itself, in a sense that, okay, through the implementation is, had I been, because when you are building the machine learning, it's like a baby that whom you are actually training and making him realize, you don't have to deviate from the exact path, but you need to understand and make intelligent decisions. That's what our end goal is. And the intelligent decisions at the end of the day should be human comprehensible. So I think from understanding the perspective of the users is one such. The second is going behind the mathematics. I love actually a lot of maths. So whenever we are building any regression models, or maybe like classification model, there's a lot of maths involved behind it. So maybe starting from the very basics, there is an equation. If you can condense your problem statement to an equation, and then try to simulate that equation and extract the features out of it, or extract the output out of it, can we actually build a framework around it? So I think that would be possible guess for me. But that's a good question. Thank you so much for asking.